Houdini 18 shipped with a powerful new feature called Solaris. With Solaris, we can load in any geometry supported by Houdini. In this case, it will be an alembic scene. We can then assign materials, and then we can gather those objects and create interesting hierarchies. And then finally, we can add cameras, place those objects inside of our scene, add lights, and render. And that's the great part here, is we can render with a whole bunch of different render delegates using the exact same network, the exact same lights, and the exact same cameras, and the exact same geometry. Hi, my name is Jeff Wagner, and for the next little while, we're going to see how to do all of these things inside of Houdini. To get started, let's first take a look at where we want to be when we finish this first exercise. And we want to be in a position where we can place objects, add materials, tweak those materials, tweak the placement, those pieces, and then start building upon the image that we want to do. This is all within the framework of the RenderMan ShipShape Art Challenge that we'll be taking a look at it a bit. So quick tour of the hierarchy. Here we have a graph, and this is inside of this new network type called Solaris or LOPS. And here I have some SOP import where I'm loading in some geometry from SOP context. I found out through experimentation the best way to bring in Alembic, which all this archive is from Pixar, is through SOPs, and it gives us a lot of interesting ways to shape that geometry to really help us as we work with it. And then we can add material libraries, and just using what do we need, what do we want, create those materials, and then assign those materials to each part of the model. In this case, I have several of these assigned material nodes where I would go through each piece individually. And then we also want to take a look at using the prune operator, which allows us to prune each one of the pieces that we're working with. And you can see that the top of the hierarchy reflects whatever it is that I'm working on right now. So if I select these operators, I can see this scene graph compose right underneath me. I can select one of these operators, and I can see this first material operator starts adding to our scene graph. And that's the main principle that we're working with here, is each one of these operators we adding, just like our geometry network does, which we call SOPs. The way that they cook, the way that they work, has been a great inspiration to the way that we've organized things inside of LOPS. One of the interesting ways is these nodes that we can use to compose our USD scenes. So we might do our look development up here, and then we can add a root operator that's called /geometry, and then we can use these graphed operators. There's a whole bunch of different operators that are used to merge the scenes together. And then as we poke down, you can see how the scene graph adjusts and builds accordingly, exactly the way that we want to, in an organized fashion, so that if I have to pass this scene layout to a lighter, the lighter will be able to easily see where I've created my cameras, where I've created my geometry, and then they can start adding their geometry lights in a separate area. And each one of these steps we can save this data and work with, or just plow ahead on yourself and have some fun. All the while we've been rendering with the RenderMan delegate as well. You can see here there's different render delegates that we can choose from Houdini GL to RenderMan 23.2. So let's now start from scratch and see what we can do. Let's close this scene, and let's go to a fresh Houdini, which I have up and running. And first thing I'm going to do is let's create some geometry, and this time we're going to do it inside of the object context. And for that, I'm just going to put down a simple geometry container. Let's call this ShipShape, and dive inside. Just tap the I key is the quickest way. You can see we have these nice jump buttons that we sometimes show you. And Houdini comes with a wealth of operators to bring geometry in, and because we know that the data we wish to bring in is alembic, let's put down an alembic operator. And when we place the alembic operator, it loads in a default cube. And after this operator, we want to load in our scene. And I have it down here. I downloaded it, and to get this geometry, we'll have a look at it in a bit. You go to the website, RenderMan website, you log into their forums, you get RenderMan, and you can access the geometry once you're accepted and you're in. We're going to have a look at how to configure all that inside of Houdini in a moment. But in the meantime, let's load this geometry in. And it's quite large. It's no surprise that this geometry is modeled in centimeters. As an aside, I'm using the technical desktop. You might be using build. So if just to match that, I'm going to stow this, and I'm going to stow this for now so we can have an equivalent look. It's just that this will be flopped for you if you're using the technical desktop versus the build. Now with the Alembic archive loaded in, we have a whole bunch of different information, and let's inspect that. So in one of these stow bars, I have my spreadsheet, and we can inspect some of the geometry. First of all, we want to control middle mouse on the Alembic operator, and that opens up some of the detailed information that we have. We can see that, sure enough, it's in centimeters units. A typical tugboat, which I'm sort of following this on, usually has a size, and we're looking at the length in Z, which is the length from the beginning to the end of the boat. And you can see it's around 22 meters. And how do I know that? Well, like you're always supposed to do a bit of reference. And I've got some website here we're going to take a look at, but it doesn't take much to basically take a look to see what the size of a tugboat is. Pretty straightforward, 20 to 32 meters. So we know that we're in the right ballpark, at least with size. I like to work in meters, so I'm going to put down a transform operator, and I'm going to scale it down. You do not have to do this, by the way, if you're going straight into Solaris. You can work at centimeter units. I just prefer to work at meter units simply because I may want to run some smoke simulations at a later point in time. And for that, 0.01 gives us a full transform. Space A gets us our entire scene. Now, let's take a look at some of the primitive information. When you bring in Alembic, it saves it to this path attribute. And this is this path attribute that will be used when we bring it into USD, into Solaris, into LOPS. And we'll see that the entire hierarchy will be built up from this path. For those of you more technical, we use intrinsics to capture all of the information with regards to the Alembic file. And this list is quite run. It runs right off the screen. So we can actually show all of these intrinsics. These is metadata. You might know this as metadata that's bound onto the Alembic primitive, which we actually load inside of Houdini. And we make use of this as well when we bring it into LOPS. And you can see that there's a whole bunch of different intrinsic data. As an artist, hide it. And as a matter of fact, just knowing that these attributes is here is good enough. Now, one more thing I'm going to do is I'm going to put down an output LOP. SOP, an output SOP. These SOPs actually, the output SOPs actually become targets, meaningful targets inside of the LOP context, and that you can actually have your flags set on different operators, and if you're pointing at the root network type, it'll actually bring in the output operator. Now let's go into Solaris. So in the technical desktop, I'm going to switch over to Solaris. And we're emptied with a brand new stage. And in the network view, I'm going to tab type, and I'm going to put down here a SOP import. And in the SOP import, we can actually pick the path that we wish to choose and find the geometry. So here we have under OBJ ship shape, and we want to bring up the output operator. And spacebar A shows us we got the full scene. Now, one of the things that we can do to improve our quality of life a lot inside of the context here is taking a very close look at kind. I like to have kind defined, and it's a USD concept that allows us to gather and assign a specific type of what is this really represent. And inside of kind, there's several different denotations of type model. And we can actually open this up in the primitive definition. And under kind authoring, I always turn this on. And invariably, if I'm dealing with a dense hierarchy of geometry, which is what we have here, you can set this final option, which is nested geometry in groups. Now notice at first, kind has only got component at the very root level. And that's pretty basic bare bones. We don't want that. We want to have all the different primitives inside of it. So we're going to choose nested assembly, groups, and components. Once we do that, we can now see that we have an assembly at the root for all of our different primitives. We also have groups for all the different containers. And then finally, the very final leaf operators where we have is the component. And why does that really matter? Well, one thing, it helps us know at a glance as to what is it we're working on. Are we working on a component, or are we working on a group, or are we working on the entire assembly? And we can see here at the root level, we have the boat sci-fi. We also have some butterfly geometry. We have the robot, and we have the sextant, all in our scene. And one thing that we can do here is on the right mouse button, we actually have the same representative down here. We have leaf primitive, which will always pick the last node in our leaf branch. We can pick components. We can pick a subcomponent of that if we had groups on our geometry that actually come in as shading subcomponents. We can also bring in group and assembly. So if we wanted to only transform at the assembly level, I could actually pick assembly. And for instance, I can pick my tugboat here. If I turn off secure selection and I box select my tugboat, you can see that now we're just picking the root assembly operator. On the other hand, if I right mouse on this and I say choose the leaf primitive and I select this entire tugboat, you can see that we now pick all the leaves. And once we're dealing with very, very large scenes, it's important that you use this kind and use the selectors effectively to limit what it is you work on and what it is you're working. For instance, if I put a transform on all the leaf primitives of this boat, I would be adding a transform on all the leaf primitives. But on the other hand, if I want to just move the entire boat, I would definitely do it at the assembly level. And then if you pick your boat, you can now see you pick the assembly. So that's the important part about kind authoring and getting your geometry done correctly inside of Solaris. And now on to rendering. So we can deselect everything, Shift N, and we want to take a look at the render delegates. So far we've been working with the Houdini GL delegate. And if we have RenderMan installed correctly, we can, if you just installed it along with RenderMan to Houdini tools, you can now invoke RenderMan. And we're going to take a look at how to actually install RenderMan if you haven't done that yet. And for that, we're going to have a look at the website. So now let's take a look at the Pixar's main website. So go there if you haven't done already and you haven't installed RenderMan yet, or if you have, maybe you want to upgrade to the latest version of RenderMan. So you will have a login that you can access up in here and you can see your settings and get it. But if you don't have your login yet, please press the Get RenderMan button, follow the steps, give them your information, and then get RenderMan, or at least get to the download page. And once you're in the download page, download, I'll show you what it is that I downloaded. And let's go to my, there we go. There's my RenderMan repository directory of files. And you can see here the two key pieces you want to download is RenderMan. In this case, I've got 23.2 underbar 2046.858, and it's just the latest version of RenderMan 23.2. So you want to download the Pro server and you want to download RenderMan for Houdini. Run those, install them, whether you're on Mac, Windows, or Linux. I'm on Windows, so double click and install these two. And the next step is you then have to manage your environment. And for that, once again, going back to the RenderMan, they've got great RenderMan docs, especially on Houdini. And if you press the installation of RenderMan for Houdini, you get the installation instructions. Follow these to the T. I'm warning you, follow them to the T. Order matters very much. And what you want to do is you want to edit Houdini.env file, or pardon me, I'll show you which file you want to edit right now. There's a Houdini environment file that is installed in your home directory, or where you have all your home settings for Houdini. On Windows, this would be in your user directory, documents, Houdini 18, and inside of there's a Houdini.env file. And the RenderMan instructions follow you to add these lines specifically. And if you have other render delegates installed, such as Arnold or Redshift or other delegates, make sure RenderMan is last. It really wants, especially this path variable here, you have to make sure that path equals rman tree/bin, and then the semicolon on Windows or colon on Mac and Linux, and then the ampersand sign, which evaluates to the default Houdini path inside of this environment. And then you're up and running. So if you want, pause the video, type these lines out, or go to the Houdini, or go to the RenderMan help and install from there. So once you have the environment installed, let's head back to Houdini. Relaunching Houdini should actually give us the RenderMan delegate if you haven't got it before. You should now be able to choose RenderMan 23.2, waits a few seconds, then it starts rendering away in the Hydra view. It also ships with a couple other tools, and I'll show you those right now. They have a material browser and also a material texture handler. And I'm going to split this left to right. So this is off your screen, but I actually picked this menu and show split left to right. And I'm going to right mouse on this, and I'm going to actually set this to the RenderMan preset browser. This is where you get access to all the standard Pixar materials. You can also install Pixar materials in here. And you can share these materials between other instances of RenderMan or users of instances. These are completely shareable with anybody, let's say in Maya or other applications where Pixar supports this browser. And over here, we want to press on this and we do new pane tab type, and let's actually put down the texture manager in here. And you can point this at a directory that contains a bunch of different formats such as JPEG, GIF, TIFF, and it'll start immediately converting them to RenderMan's text format, which are pretty much usable by the materials. What I'm going to do though is a bit different. I'm going to start prototyping my materials as a first pass using Karma shaders, believe it or not. And I'm going to rely on this automatic mechanism that converts materials to this USD preview shader, which is also used by RenderMan and Karma. But in this case, we're going to be using it to do a first pass at materials inside of RenderMan. So if I put down a material library down in here and place that down on my network and just simply wire it up. And now we can see here that nothing's changed to our archive because there's no materials inside of here yet. So we're going to inspect the scene and see what sort of materials we want to use. And so we have here the hull of the ship. We can pick a color. There's lots of decorations. And you can actually pick those pieces of geometry that you want. Let's actually pick, let's pick at the component level. And we can now start picking some of these pieces of geometry. And for this, I'm going to go to Houdini GL. And you can see here, you can pick on the various different pieces of geometry. And I have secure selection off, which allows me to freely select these things. And I'm going to drag this over a bit and move this over a bit. And you can see here, as we start picking these various different pieces, you can see that we select them in the viewport. We can see exactly what we're working on. We can inspect the hierarchy and see what we're sort of working with here. So for instance, on this boat, we see that there's a whole bunch of hull boards. And there is also a top deck group, which has all the different pieces to it. We can see that there's doors and so on and so forth. So you can inspect the hierarchy. We're at the mercy of the modeler, and this modeler did a decent job at, or the modelers did a decent job of delineating the various pieces of these models as it relates to materials, and also for placing some things. If we take a look at the actual large boat itself, the boat sci-fi object, we'll notice that unfortunately for us Houdini users, the thrusters are all in a single group. And that means that we can't articulate these. So if we were to articulate these, we'd actually have to go inside of SOPs and start working on them from that way and break it apart and reconfigure the hierarchy. But for now, first pass, that's great. But we can see that we have a whole bunch of different pieces in the mechanical, the cabin, and the ship hull. So very quickly you can select these things and you can see what it is that we're working with. There's also a couple other pieces of geometry. There's a robot, and there's a sextant over here. And there's a butterfly over here. So what we want to do is, when we're creating these materials, we can use what's called a prune operator. And I'm going to put down a prune lop and wire it between my SOP imp and the material library. As a matter of fact, let's put it after the material library. And this allows us now to hide or isolate those pieces of geometry that we wish to work with. And I'm going to go to the parameter pane here. And I'm going to drag this texture library over to here. And as a matter of fact, I'm probably going to move my material palette up over to here too. So I'm going to move that up here. And I'm going to be working with my material palette here in a bit. We can see that the material library actually shows up there, and that's what we're going to focus on. So you can see that there's several material networks inside of the Houdini scene. We're going to work with stage material library 1. And we put the prune down. Let's actually work on the small shipwreck boat. And for that, we can see here that if we right mouse and we basically collapse all. Actually, the root level, let's collapse all. And now we can see here, just open that one up. And we have the sci-fi, the boat, and the robot. We want to work on the pup boat first. So I'm going to drag and drop that into our primitive pattern. And just like a lot of the operators that we have in the geometry context, we can actually prune unselected and space G. So now we can start working on this tugboat. And I'm just going to put down 2 base materials to get you all started in how this thing works. And I'm going to put down, going to go inside of the material library And let's say we're going to have a wood material and let's say a base material to get us started on the material. So I'm actually going to put down a principled shader, which is a shader normally designed to work with our own renderer Karma. And as I said before, I'm anticipating that this material will be converted, well, there's be another material created that is also a USD preview shader that can be used by all render delegates inside of the viewport. Or at least that's the idea. So let's call this weathered boards, or let's actually do this properly. Wood weathered boards. So I always like to put the classification of material, then an identifier afterwards. So the wood weathered boards, and for this base color, we're going to set it to white because we're going to rely on a texture map. At least I've got a library of textures, and so under the texture here, let's actually stow this pane for now. And let's press this. Now inside of here, I've got under assets, I've got a little texture folder in here. And let's just use this wood texture. Notice how I aligned the boards vertically. For some reason, this modeler has the UVs aligned so that they're upright. And it coincides with my boards. And so now we got wood weathered boards. And as I said before, I'm going to alt drag a copy of this. And in this particular directory, I know the UVs are pretty messed up for the cabin. So, and I'm just going to go here and I'm going to make my cabin, let's make it a dark color or something like that, and make it pretty dark just for now, just creating some. And let's call this let's call this metal, rusted, weathered, and we'll just use it as a texture slot for now. But we have two materials. Now what I want to do is do assign material. And in the assign material, this is where we want to assign the materials. And what I'm going to do is I'm going to do as my material, as mat, underbore, and we're going to do pup boat. So let's do 2 underbars, pup boat. And this is where I would assign all the materials for my pup boat. So we're just going to do the pup boat for now. And in here, we're going to do 2 texture slots for now. So let's put 2. And here I'm going to actually use the scene graph to drag the various different components that we want for the boat itself. So I'm going to stop this and just open up the boat. And this part is really fun. So we can actually dive down in here and we can see below deck group. And we want to assign the weather material to that. So the material path, we'll do that in a bit. And with the top deck, let's use that for the second slot. Now, one of the things that we need to do is we have the material library. It's got 2 materials in it. And I'm going to double click and dive inside of this. We can see that wherever we have this material flag set, these nodes are being considered materials. So what we have to do is under the material library, we need to press this button, autofill materials. So whenever you add or remove a material in the material library, you have to press this button. And what this does is it actually constructs inside of USD the materials. So these materials are actually saved inside of the USD scene. And here we can see our materials. And we can see we have rusted, weathered, and weathered boards. So now we can go back to our material that we're using for the assignment. We want to do the weathered boards. And then we also want to do the metal weathered. So we're going to grab the metal weathered and drag that down there. Now we're seeing this in Houdini GL. Now, as I said before, if we go to the material library, we'll notice here that there's an option called auto generate preview surface shaders. So we can actually do our first pass materials using Karma shaders, and they actually work very well with RenderMan. So you can go pretty far with this before you start building complementary materials or more composite materials. But if we go to RenderMan 23.2, it'll actually auto-convert the textures for you, assign them in the materials, and actually work with RenderMan. So we don't need necessarily to convert the textures, although there is a bit of a hit obviously in that RenderMan needs to convert these textures, but there is an automatic way to actually use these shaders. And as I said before, when we first started this whole exercise, the proof, you would simply set this to all the other boats and you'd assign all the materials that way. Now, one of the things that you also want to do is Because we want to do further work on this to place these various objects, you can actually bypass the prune lop. And notice what the prune lop actually does inside of the scene graph. It just simply controls the visibility of your payloads or the geometry in your scene. So that's the first stab at assigning materials. Going back to our start scene, the scene that I started off the whole presentation with, we took a look at the various structure of the USD graph, and you can see here that I have my prune lop that I use to isolate. I actually put it before the material library. Doesn't matter whether it's before or after. But here you can see all the various different texture slots where I actually assigned those materials. And using RenderMan, you can see here there's the both sci-fi got set dressed, and then the pup robot is actually set dressed. So I did it first pass the materials on the robot, and also the sextant, which is over here. And we're all leading up to actually adding a proper camera. And then there's the pup butterfly, which I just did some basic stuff. Now there's no rigging at all done. It's just all basically just some basic assignments with the materials. So we got the materials down first pass. Now what we want to do is figure out a way to build up a proper hierarchy inside of the scene, because we want to add a camera. And to add a camera, we can then place our objects. And once we've placed our objects, we can then light. And then when we finally do lighting, we can then render and finish our job. So that's the next thing that we're going to do. So let's go back to our previous scene that we've been working on. Please go ahead and assign all the other materials. You also notice in the other one, I actually added an ocean as well. And I just went into the SOP context, used this option, creating context, and added an ocean to that other object. And you can do more, add smoke, atmospherics. It's up to you what you want to do inside of SOP context. But it's nice having that SOP context, because you can now start rigging the boat. You can animate it. You can do all kinds of things. And if you do animate the boat, just make sure to go to the SOP import. And it's already set up to under the import handling path. It really wants to handle things in such a way that you can actually, it assumes that if the SOPs are time dependent, then it assumes that it's time dependent, and then depending on the frame range that you cache later on, it'll bring in that caching for you. So be aware that that's the case. If you have animated geometry, it'll actually bring in animated geometry and create and basically update the geometry every time you change the frame. So now we're going back, and we see that everything's at the root level, but we want to add a camera. So if we add a camera, I'm going to once again just go to Houdini GL for now, and make sure that my prune is bypassed, and space A. And let's say we want to frame the camera something like this, and we know that this is going to be our key object, and we want to frame the camera maybe overlooking the bow of the ship down into the distance. And we can adjust this camera later on if we want. But what I'm going to do now is I'm going to control click on the camera object on the shelf, hold down the control key, and then pressing the camera automatically creates a camera for us. And like all cameras, if we go to the view setting, we can see that the horizontal aperture is 20. I like using a horizontal aperture 25.8 to 25.9, which is more in keeping with a 35mm film back. And I like the vertical aperture. Let's keep it that way. Now we can start using a focal length that's more realistic. So let's use a 100mm lens on a 35mm film back. And now I can lock this camera, and we can start placing our cameras. And let's move it back a bit. And let's see if that's good enough for now. So we zoom out a bit, and now let's take a look at the hierarchy itself. We can see that the camera is in the same level as all the different pieces. And we want to parent these to, let's say, a geometry transform, or a geometry group, or a geometry place in the scene graph, and leave the cameras always dropping in where the camera directory is. And let's zoom out a bit and inspect what we have. We have got some geometry in here. We haven't saved any USD to disk, so that means we're currently working with everything inside of memory. No problem. This scene is actually quite small, so we really don't have much of a memory footprint. But that means that we can use a node called Graft. And Graft is a very powerful node that allows us to actually reparent or reposition things inside of the scene graph. And I'm going to put a graph operator down. It takes a bit of time because it's actually rebuilding the entire graph for me. And you can see here now that it's actually put it inside of a root, which is actually the name of the input operator. And we want to put down, in here we can actually put down a transform node or an xform node. There we go. And we can create a transformer and wire that in there. And this can become our root operator. And you notice that the primitive path is already defaulting to geometry. And if we select this operator, we can see that we have a geometry path. Graph does is it'll actually take whatever geometry is in here and graft it into any position within the scene graph location that we have here. So if we press the graft, we can now see that we have geometry, and we still have this one assembly on top of all the different assemblies. If we wish to keep that, we can do that. And what it's actually pointing to is this destination path data. And if I use my middle mouse button on here, you can see that it's create transform. And the primitive path location is actually /geometry, which is all good. But we want to basically just set this to / and put everything at the root level. So now we just have geometry, and then we have our pup boat and pup. We just want everything to live inside of here. If we want, we can actually put in here pup underbar geo and put a trailing /, hit enter, and we can see we can actually reparent it that way. What's important here is that this path that we graphed this part of the branch to is going to affect everything that we do downstream. And so we really want to make sure that everything is inside of this container folder called geometry. That's what I do. Different facilities will do different things. I'm following sort of the Pixar standard where or just a standard where everything is geometry, goes into geometry folder. And now what we can do is we could actually wire this camera right in line now and work simply after that. So, and the only reason we had to use the graft is simply because we were bringing in USD data. If this was not USD data, it was just standard Houdini geometry, I could actually have changed import path prefix to /geometry and have avoided the graft. But because we're dealing with Alembic data gets converted into USD, this has no bearing. The USD path overrides all of this. So it's just the way USD comes in. So we're going to go back to the camera, and now we got our camera all set up. We can take a look through our camera. And now we can start placing things in our scene. And as I said before, we can go here, we can right mouse on this, and we can choose to move everything at the assembly level. So we want to move everything at this assembly level here. So we have transform does not have a kind, which is going to help us out a bit. And we can see here we have the pup geo, and we have all this different geometry here. And I said I didn't want pup geo, so I'm going to go back to this graft operator, and I'm just going to put a / in here. I'm just going to put everything under root for now. Choose whatever you want. It's up to you. It's USD. So in the camera, the next thing we want to do is now start using an edit lop. So tab edit, and we can use this to place our geometry in the scene however you want. And so we put that down there. And now we can actually use our selector, secure selection off. We can select our, I'm going to send future to console. Now we can start picking our tugboat. And you notice that if we put a transform on this T, we can now start moving this tugboat. And if I actually would have selected it in the viewport, we've actually would have gotten the correct handle in the correct location. But you can now start using this to actually move the various pieces in your EC. Now it's in the right location. So that's the difference between selecting into the viewport versus selecting the scene graph at this point in time. Is you get the handles in the right location. And you can position your props wherever you want. You can move the robot wherever you want. You can move all the different places wherever you want. So go ahead and feel free and do that. As I said, this is just to get you on your way. And once we get the edits, we can actually put here position props. And then next one we do is just add some lights. So in this particular scene, we want to add a dome light. So dome light is an environment light. And we just put it at the origin, hit enter, and you can see where's the dome light. And in typical USD fashion, we have our cameras, we have our geometry, and we have our lights. That's the point I'm trying to make here, is that really simple to work with, really simple to organize your geometry. And once it's organized this way, it becomes second nature. And then finally we get the dome light. Under base properties, let's add a nice environment map. I'm just going to go to the HFS settings. So under HFS, where is that? HFS Houdini picks textures, and we actually have some environments. And I'm just going to choose one of these environment lights. Pick a nicer one. I'm using a garage. Let's use this one here. And now we're getting the scene environment. And of course, we can go back to RenderMan. We're all rendering. And again, now start putting other props, positioning them, building other objects, and you're well on your way. And that's it for now. Thank you very much for listening on, and good luck with the contest. And hopefully you'll choose to use Solaris and LOPS and using RenderMan with the materials. Thank you very much.